with this rotor design assignment, and I haven't checked your documents yet at all. I think next week I will give you feedback and the grade for this assignment, but so far I haven't checked them at all. Is everything okay with this task, or is there something that you want to discuss before we start new thing?
Actually, Simo, I have some questions.
Okay.
I couldn't made section views while making drawing.
Okay.
And I don't know why I couldn't make that section views.
So was it so that the software crashed, or what was the problem?
No, when I press for the section views, and it will not show anything, and it will just froze, and I have to close that windows.
Okay. And you were using this virtual
VMware.
desktop
Yes.
VMware. Okay. Did you check that you have the most latest version of this VMware?
What do you mean? Most latest version means?
I mean that have you updated the software?
No, I haven't updated it, but I used to use VDI. Wait a minute. Yeah, I used to use VDI.loop.fi.
So you don't have this software installed in your computer?
I have. So I need to update this one.
Let me show you if I share the screen and how it is in my computer. Just a moment. So you see my screen now, and I have this VMware Horizon Client software. Do you have the same?
Yes.
And when it opens, I think here in options there is a place where you can check the software updates. And for me now it says that I have already the latest version. Can you check that? Do you have it also?
I didn't have, so I'm updating now.
All right. I'm not sure whether this is the thing, but always I have been told that you should use the latest version. And then when it is updated, then also please make sure that you will run the SolidWorks settings before you open SolidWorks itself.
Okay.
Do you know what settings I mean?
Yes.
This is what you can find here.
Yes, SW and custom work. Yes.
Yeah. So this should be run before you open the SolidWorks. Okay.
Simo?
Yes.
Yeah, what is the main reason that SolidWorks repeatedly get crashed? Yeah, so I could so in my case, yeah, I got several times same kind of crash. Yeah, yes, I have taken some pictures also. So during when I'm doing that PDM exercise, so
Uh, I can't tell. I don't know, because some student reports that it crashes, but then other students everything goes well. I really have no idea if you are just using this virtual desktop in the same way as others. So I think you should report to this IT people if this kind of problems occurs all the time.
okay, thank you.
But in your case, did you see the way how I checked whether I have the newest version of this VMware?
Yeah, last time, yeah, the Beamer was not working, so I updated and new app. So
Okay, so you have the latest version, but still you run some problems with SolidWorks.
yeah, exactly. So
Okay.
so I couldn't meet the deadline also, and I have sent you a mail also. So
Okay. Yes.
I hope I can do also.
If you have faced these problems, you can send still the documents to me via email.
Okay, definitely. Thank you so much.
All right. But let's continue topic of today. And now we are going to talk about machine safety. And why this is important when we talk about machine design. There are certain legislation. Of course, the safety is important, very important by itself, but there is also some legislation behind it that there are some demands for manufacturers of the devices and machines that they have to follow certain procedure to make sure that the machines that are designed are safe. And now we are going to have a look about what kind of rules exists. And I have a document machinery directive here, a PDF file, and also there is a link which lets you directly to the directive itself. But let's have a look at my PDF document, and the first question here is that do you have any kind of idea that what kind of documents and things are required if you are designing a completely new product, in this case an example, a drilling machine, and you plan to manufacture and sell it inside Europe, for example in Germany and Finland? So what are the things that you should take account? What kind of documents you need before you can start manufacture and sell the products?
Is that safety factors?
Mm-hmm. But do you have more specified guesses that what kind of things? Have you heard about CE mark?
Sorry.
The CE mark kind of points out that when certain product has been designed, then the rules of the European Union has been followed while doing the design, or European not European Union, but this European community, to say so. There are other countries than European Union countries also. Okay, but we are going to have a look what are these things. This was just a pre-question that do you have any clue what is coming? So we are basically talking about a directive which is called Machinery Directive, and then the machine safety behind it. And at first I need to define that what is Machinery Directive. It's a directive that defines what a manufacturer or importer has to do before launching the product for manufacturing and selling. And it is applicable for every new machine inside European Union. And it also includes individual products, even though there is only one product which is manufactured. And in theory, also, it is including all the products that are made for personal purpose. So even though you are not going to sell a product, but you manufacture it for yourself or for your own company, still you should follow the rules of the Machinery Directive. And this importer means that, for example, if originally the machine is manufactured outside of the European Union, for example, it is manufactured in China, and then it is imported to Finland, you need to make sure, or the company that imports this machine to Finland have to make sure that it still follows the Machinery Directive. There is a big list of machines that should be applied in this directive, and this is the direct list taken in from the directive. It says machinery in general, meaning more or less every type of machine. But still there is some specific list, including interchangeable equipment like this shaft here, safety components, lifting accessories, chains, ropes and webbing, removable mechanical transmission devices, partly completed machinery. Then there is also another list of the devices that are excluded. I'm not going to read all the information here, but just to pick some. For example, weapons are not included in this Machinery Directive, or some amusement park devices, and also some agricultural tractors, because they have all these things, they have their own directives where are specified certain things more deeply compared to this general Machinery Directive. Then this is once again taken directly from a directive. There is a text what tells what is machinery. Now I will give you 1 minute time to read this, and then we can discuss whether you understand what it is or not. So take your time and read this text, which is blue now. Okay, so what is your feeling? Is it easy text to understand? My opinion is that it is not so easy to find out that what is the clue here, that what is really said there, because it seems that this is only a one very big sentence. And but what it tries to say in a nutshell, I would say that parts and component has to be connected together before the product can be called machinery, and a product has to be able to use for some special purpose without adding any additional parts. Then you can call it a machine. Also, this continues. There was a word, partly completed machinery. What does it mean? Well, the partly completed machinery is almost like a real machine, but it is not fully assembled. It means that it has to go through at least one stage of completion before you can call it a real machinery. And see, this device should be very familiar to you now, because you have been designing this several weeks. This is an example of partly completed machinery. You can't call this rotary feeder a machinery because it is not meant to work alone, but it is meant that it will be assembled into some other bigger device, for example, on a boiler or at the bottom of some silo, and they together can be called machine. But this rotary feeder itself, it is partly completed machinery, because there is still one stage of completion left. Also, the internal combustion engine, it is not a machine, but it is partly completed machinery, because the same reason, you are not using this kind of engine alone, but you are installing it to, for example, some vehicle, and after that they fulfill this machinery itself. And there is a little bit different demand for partly completed machinery and machinery. And that's why there is this dividing between them. Okay, then the directive gives 6 different steps what you need to do before you can place a new machine on the market. And this is the list. At first, you need to carry out the appropriate procedures for assessing conformity in accordance with Article 12. Then you have to make sure that technical file is available. You need to provide instructions. You need to draw up the EC Declaration of Conformity. You have to affix the CE marking. And finally, you have to make sure that the machine satisfied relevant essential health and safety requirements. And now we are going to have a look what each of these things means. And you will find the same information, or let's say more deeply this information directly here. There is this machinery directive, like I told, this is the directive itself. 63 pages of information. And if we have a look at here, Article 5, placing on the market and putting into service, it is told the same things that there are in my list. They are here in a little bit different order, but anyway. Okay, but at first you have to find out that how you should go on, and this first thing basically means that you need to follow this kind of flow chart. So at first, if you start here, you have found out that you have a machine, not partly complete machine. You need to create at any way, you need to create technical files and instructions. And then there is a question that do you have a machinery which is listed in Annex 4, or do you have a machine which is not listed in Annex 4? And what does it mean? What is this annex? We can go here and check. Check the annex. Where does it begin? This is the Annex 4, categories of machinery to which one of the procedures referred in Article 12 must be applied. And then there is a specific list: circular saws, sewing machinery, hand-fed surface planing machinery, and so on, injection or compression, plastic molding machinery. There is a list of special machinery, and if the machine that you are going to design at the moment belongs into this list, then you need to do a little bit more, to say so. So this list in this Annex 4 is a list of more dangerous machines. And then there is more detailed rules what needs to be done. Okay, if the answer is yes, my machine is in this list, for example, it is a chainsaw, then you still have two different options. If there is some fully harmonized standard how to design this specific machine, and you are following this standard fully, then you have three different options what to pick. You can have a full quality assurance, which is checked by some third-party company or institution, or you can have this easy type examination, once again made by an institution outside of the original company, and internal checks on manufacturer. And the easiest way is this assessment of conformity with internal checks on manufacturer. This means that the company itself puts the limits and targets and checks that everything goes on, and it is fully following the directive, and no other institution or company outside is coming to check whether you are working in a correct way or not, but this is fully inside the company happening thing. So 3 different possibilities here. But if the answer in here is that yes, I want to do it, or I have still the machinery in this Annex 4, but I'm not going to do it based on the fully harmonized standard, or that kind of standard is not present at all, then you have only these 2 different options, which means that there is some institution, external institution, that comes to your company and checks whether you are doing it in a correct way or not. And if the machine is not listed in this Annex 4 at all, then you will go directly here, so that you have only internal checks within the company. And after this is done, then you're able to create easy declaration of conformity and fix the CE marking. And like I told, this partly completed machinery, it is more easy. You still need to create this technical documentation and instructions, but that's it. Then you create declaration of incorporation, but you don't need to think about these things at all. So this was the first step in this 6-step list. It was this carrying out appropriate procedures. So it was just finding your own way. So this was the step number 1. Then in my list, the step number 2 is that you have to make sure that technical file is available. And what is a technical file? It's a list of all documents that you have used and created while doing the design for the product. So basically, the technical file has to point out that the machinery complies with the directive. It has to be made in some of the European Union official languages, and it must be available at least 10 years after you have stopped manufacturing certain component. And our company has to name a person who will create this technical file if asked. So this is something that you are not going to put together with the machine to a customer, but this is something that you have to create in your own company. And if there are some safety issues later, then some people might ask that, do you have the technical file? And you have to give the technical file in certain time so that some external institution is studying whether it has been done in a correct way or not, or if there are some safety issues in the design. So basically, the contents, all kind of drawings that you made, all calculations that you have made during the design. If you have done any test results, they should be here in technical file. And also there should be a risk assessment documents. I will talk more about this risk assessment a bit later. Okay. Then the next step is that you need to provide instructions. And once again, these instructions, they have to be made with some official languages, and then they need to be translated to target country language. And the contents of the instructions, there has been such drawings, charts, diagrams, and descriptions that are necessary for use, service, or repair of the machinery, meaning not all drawings, but only such which are necessary. There has to be descriptions of suitable working methods, and of course instructions for operation itself, and also instructions for service. These are the minimum requirements. Then draw up the EC declaration of conformity. This might sound complicated, but I think this is the most easiest part of this list, because this means only one sheet of paper, A4, that has certain sentences, and then some people need to sign the paper to make sure that everything is done according to this directive. So basically it could look like this. Well, this is a finished text in this paper, but there are just some sentences that are told in this directive. Basically, it says that the machine follows this and that standard, and it is made according to directive. And finally, there is a signature of the person who guarantees that everything really has been done according to the directive. And usually this person who signs this, it's the general manager of the company, or some kind of a leading person in a company, because that kind of person can guarantee that everything is done according to directive. And if there are some safety issues, if there are some hazards, and some people insure themselves, and it might be then that this person who has signed the paper might get some fees or some other punishments if later is found that the directive is not followed, even though this kind of paper is signed. So my advice is that you should not sign this kind of paper if you are not fully sure that all the rules are really followed. Then number 5 in this list is to fix the CE marking. This is also pretty straightforward and simple. In a machine, you need to have a marking, kind of a type plate that tells the manufacturer name and address, name of the machine, then this CE marking, and serial or type number of the machine, and a manufacturing year. You can put some other technical details in this typelet also, like in this example, there are powers and rotating speeds and other information, but these are the things that the directive says that the minimum you have to have these. And this CE marking itself, it needs to be done with this one special format. It's not just that you type letters C and E, but it has to look like this. And you can find this kind of CE marking in many different places. It's not only machines, this is not only the machinery directive thing, but it says that in a product where you find the CE marking, it means that some of the European nation directives, European Union directives have been followed. There are many other directives than machinery directive. I'm pretty sure that if you turn around your mouse and in the bottom of your mouse you can find the CE marking for example, even though your mouse is not a machine. And the CE, it comes out of the words, the French words conformité européenne. I don't know how to pronounce this, but it means something like European conformity. All right, and the final step, the last but not least step, is that you have to make sure that the product satisfies all the relevant and essential health and safety requirements. So more or less all the first 5 steps, they have been documents and papers and such, but this step really is one of the most important, because this is the place where you have to make sure that the product that you design and manufacture is really safe. So this, what it includes? Well, essential health and safety requirements. What are the general principles? You need to define limits for your machinery. You have to say that what kind of use is okay, what kind of use is forbidden. Also, you need to identify hazards, and you need to estimate and evaluate what kind of risks there are when you operate with the machine. And the general principle says that there is 3 steps to eliminate risks. The first step is that you have to use this so-called constructive ways. You need to eliminate or reduce risks as far as possible with safe design and construction. And after you have done this, if it's not enough, then you can add some protective measures, meaning safety cards or some kind of sensors. And if it's still not enough, if there's still some kind of risks residual risks available, you need to inform users of those risks and specify what kind of personal protective equipment you need when you work with the machinery. So you need to informate about the danger. But you can't start from here. You can't just say that be aware this is a dangerous machine, but first you need to go through this step 1 to find out how to make the construction safe itself. Then if it's not enough, then you need to put these guards and safety sensors, and if it's still not enough, then you can place some signs that there is still some danger left. So what might it mean, this stage 1? Well, you have to select safe technology if possible. Then you can place some dangerous parts and moving parts of your machine inside, for example, inside a frame, if it's possible, so that those dangerous objects are not even visible. And then when you do and calculate things, you have to follow general rules for machine design, for example, so that you will use safety factors big enough and so on. And if possible, you need to prevent the unwanted way of use of the machine. So in here, for example, one example how to make the safe design is that if you have this kind of a belt conveyor and there is a gap between some stationary bar and a belt, moving belt, if the gap is small enough, then it becomes safe. It says here, this is in Finnish, but it says that if the gap is less than 5 millimeters, there is no danger that your finger or any other part would damage here. And you see this kind of belt conveyors more or less every day. Well, not maybe every day, but very often when you go to the grocery shop, to S-Market or K-Market or Lidl to buy something. And if you pay attention that what kind of gap there is between the belt conveyor and the table, you will notice that the gap is very, very small and there is no risk that someone could put the finger here. But if it would be larger, then there would be a risk for crushing your finger, for example. This is an example that you should not put just the sign there, but make the design so that there really is no danger. Also, if there is some instrument or measuring device where you need to read some numbers often, it is not okay that it is so far away that you are not able to see it well. It is not okay that you need to create some pile of boxes so that you're able to see it. Or it is not okay that you need to use some ladders. But there are two options. You need to create a proper way and safe way so that you're able to reach the target, or I think this is the best option. You have to put the gauge, the meter in a such level that you don't need to climb anywhere, but you can see it easily. And I would say that nowadays, these kind of things, there is just some sensor inside, and then there is some a room where you can read the values from each sensor. So this is not very typical problem, I would say, anymore. More examples. If the inlet here is something between 40 millimeters and 120 millimeters, then you should have at least 850 millimeters distance to some moving and dangerous parts. This example is just taken from a standard. And another example, if you have a fence, the minimum distance to dangerous object is 120 millimeters. I think it is measured so that even though if you have a very long fingers, they are still not more than 120 millimeters, but the length of the finger is less. Then I told that when you have this technical file, you need to do this so-called risk assessment. And this risk assessment means now that all potential risks should be identified and listed. And after these risks are listed, then you need to evaluate the risk magnitude. And the magnitude consists of two different things: seriousness of the harm and likelihood of the harm. And let's have an example. How to evaluate severity of the harm. This is done by a Finnish safety expert called Tapio Siirilä. He has this kind of a scale from 1 to 100, and when you evaluate a risk, you need to evaluate that what could happen to person that is using this machine. If it's only some small scratch, it gives 10 points. But if it's, for example, you might lose your limb, then you will get 70 points from this scale. And if there is the possibility that the person who is using the machine could die, then this scale gives 100 points. And it goes roughly so that this 50 points is a limit, so that the things below here, they are something that will be healed afterwards, so that there is no such a problem that will exist the whole life later, but they will be fully healed. And the things here between 50 and 100, they are some constant failures to personal health, some harms that you are not able to heal anymore fully back to normal. And so this kind of severity needs to be evaluated for each risk that you can identify. And the next step is to find out harm likelihood. So how likely it is that this will happen during the lifetime of the machine. Once again, the scale now between 0.1 and 1, meaning that if the point is 1, the happening is definite. It's really sure that this kind of thing will happen. And 0.1 points, almost impossible to happen. And when you put these things together, you will get so-called risk magnitude, this kind of risk matrix. If you multiply the likelihood and seriousness, you get some number, and based on what number you get, you are getting a different color here: white, green, yellow, blue, or red color. And the white color means that the risk is small, green means that the risk is tolerable, yellow means that you have a moderate risk, and blue considerable, and red intolerable. And only these white and green are such that you can, let's say, accept. And if you have yellow, blue, or red color, it means that you need to continue designing so that you have to eliminate or change the construction so that this kind of risk is not there anymore. So the small means no actions needed, and tolerable can be accepted but has to be controlled, but all the other things, risk has to be decreased, and you need to improve the design. Then I have an example of dangerous machine. Have you seen this kind of machine for splitting or cutting the wood?
Not yet for me.
So in Finland, I would say 20 or 30 years ago, this kind of machinery were quite widely used in the countryside to make some wood that you can burn in a sauna oven or to heat up the houses. But it is, if it would be designed now, it would never fulfill this machinery directive. There is a huge blade rotating, spinning, high speed, and it is very, very easy to cut a finger or a hand or I don't know what. It is highly dangerous machine. How you could do the same thing in a more safe way? Some newer machinery that is used to cut and split wood looks like this, so that the dangerous part here, the saw that is cutting the wood, and the cylinder which is splitting the wood in pieces, they are in a such place so far away from the user that there is no possibility, it is not possible that the user hand goes into this dangerous object when the other hand is using the machine. So the lever, what is used to control the machine, it is inside the red box, and when the hand is there, the other hand just is not so long that it could touch this saw here. And of course, there are some fences and some other safety things, but this is the main thing, that the dangerous object is in a such place that you are not able to touch it while operating the device. So as a conclusion, this machinery directive, there is a lot of paper, a lot of bureaucracy, but the purpose is good. The aim is to create safe machines, safe devices, and less hazards. And since you work as a mechanical engineering and a mechanical designer, you have to cope with this directive. And basically, if you hear it now first time, it might sound that this is a little bit not so clear thing, but after a while, I think you will find out that the demands that this directive gives you, they are at the end quite clear and direct. Okay, then I have a task for you. One more assignment. So, risk analysis. This is something that you need to do in a group. Let's say 2 to 4 people group. And now you should select some machine that you want to study. It can be some machine that you have at home, or if you have been working in some company and you remember some machine there. Or if it's not possible, then you can pick some machine from the market, meaning that you will search from internet some particular machine, not in general, so that you will study in general, for example, chainsaw, but you should pick some specific model that you will study. And then you should follow the steps of this risk assessment procedure and create these risk assessment documents. Meaning that you have to find out what different hazards would be possible, and to list all the risks, and then evaluate the risk likelihood and severity of the risk, which gives you this risk magnitude. And if the risk magnitude is too high, find out and think how you could eliminate the risk or make the risk smaller. And you have 1 week time to do this, and next week you should introduce the result in June. And there is risk analysis groups. This is a place where you can create the groups. So you can create your own group here. And how to find out what risks could be there. Let's have a look at this risk identifying document. So this is the one safety standard, EN ISO 14121, safety of machinery risk assessment. And if we go through this, I think the most important thing is here at the end. Some examples of hazards, hazardous situations and events. So there is a list of different mechanical hazards, examples of typical mechanical hazards, examples of typical electrical hazards, thermal hazards, and so on. So there is an examples of origin of this hazard. For example, if we have a look at the mechanical hazard, if the machine has some elements which could create falling objects, or if there are some cutting parts and so on. All these kind of things could create some mechanical hazards. And what are the potential consequences for the user of the machine? What could happen to a person? There could be crushing or impact or injection or shearing or suffocation and so on. So when you have picked a device that you want to study, then you can have a look at the list and think that is there a possibility to any of these hazards? And if the answer is yes, there might be this kind of hazard, then put it in your list. And then after that, evaluate that how likely it is to happen and how severe it might be. There is more than 10 different main type of different hazards. Or okay, exactly 10 different main types. And if you go through this list, you have a quite good knowledge that if your design or if your machine really has this kind of risks or not. And there is still another list or other table, some more examples that what these different hazards could look like. For example, falling objects or cutting parts or moving elements. You could also go through this kind of list. All right. And then still one document here, example of risk assessment. This is now in Finnish, but I will explain what it means. So this is an for example, made by Excel sheet. At first, there is the user or the task, what the user is doing. Then there is the danger, and then there is this risk evaluation, and then there is how to improve the safety and the evaluation again. So I can show for here how it should look like. So when you do the task, the assignment, you could do it in the same way like in here. So that, of course, you first introduce that what is the machine. And you have to have some picture of the machine and introduce that what the machine is that you are studying and so on. But then you should create this kind of an table where you tell that, for example, like in this example, that you have a user or task, and then a hazard, and then you have an risk evaluation. The risk evaluation, it consists of this likelihood and severity, and then you get this risk magnitude. And then way to reduce risk if needed, and risk evaluation after risk. It could look like this. And now, depending on what is the machine that you study, there are different users, different tasks, different type of hazards. If I pick this example here and translate it into English, so this risk evaluation is for some kind of sawmill, and the first box here is the operator of the machine that is in danger, and the task is pick the panels from conveyor. And the hazard here is mechanical and some wood sticks. Making wounds to hands, for example. And risk evaluation, how likely it is. Now this is, in this example, they have used a Britten scale, but if we would use the Tapio-Siirilä scale, the likelihood how easily this could happen is that I would say that the likelihood is 1. It would be pretty much sure that this kind of things would happen. But then if we go here, so the happening is definite. I would say that yes, you will get some wood sticks that will create wounds or scratches to your hands. But how severe it is, if I would say 20 points, or even less, 10 to 20 points. Let's put here 20. Now this is, the magnitude is 20. And the 20 means that it is in yellow field, moderate risk. I could give here a color. It's 20. How would you reduce this risk? Well, I think it is quite straightforward. Do you have any suggestions how to prevent not to have wounds on hands?
Always remember to wear gloves.
Yes, you need to wear gloves. And then this post evaluation, then the likelihood, I would say that after you have these gloves, I think that it is not likely to have the wounds anymore. I would say it is more or less 0.2 or something like that. And the severity, I think, if there still will be some wounds, it is the same severity. But now the magnitude is much smaller. It is 4, which is in a wide area. So the risk is small. And we can say more or less that the case is closed for this line. But you should find out every possible hazard that you can imagine that could happen with that machine that you pick. So this was now just one example. So in this example, it has been done. This is not let's say the full risk evaluation, but there are some examples of what can happen to operator in different tasks. So do you now have an idea what I'm waiting for you?
So we have to have an Excel this, and do we have to need to write any other documentation?
This Excel is enough. You don't need to have any other documentation, but you should have some kind of picture. You can add the pictures in this Excel, or if you want to have other kind of document where you present the picture. But I think when you present this document to me and to your classmates, you need to have some kind of a picture where the machine is presented, so that it is easier for you to tell that what is the machine that you are talking about.
Okay, thank you.
Have you already created these groups? Okay, we have some group. Good. That's fine. And I don't have any more material that I would like to show today, but you can split into the groups and start thinking that what could be the machine that you would like to have for a closer look. And if you want to ask me that whether the idea of your machine is good or not, I'm here to answer these questions, and I can create the breakout rooms so that you can speak freely within the groups. So now there is a 4, or let's create 5 different breakout rooms, and you can go there together with your group mates, and you can start designing this thing.
Excuse me, Simo.
Yes.
I have some questions regarding the previous exercise.
Mm-hmm.
I still couldn't make that section views. I think I had some problem with my settings. So if you don't mind, can you see that once?
Yes, maybe we could do so that if you will open or share the screen, and let's have a look at your computer, how it looks like. Whether in a way you want. What do you prefer?
I think.
Excuse me. About that problem, I think the other student had the same problem, and he found the solution to that. So the section view does not work if you activate the SW settings. So in order to make a section view, you have to sign out from your account and sign up again. But this time, do not activate the SW settings and just open up the file and insert the section view.
Oh, okay.
Yes, it is exactly like this. For me also.
Okay, this was new for me. Not so nice to hear that there is some problem in the settings, but okay, it's good that at least we know then what is the problem. I need to test that by myself.
Okay, then I think I found my solution now.
Okay, good.
Thank you. Thank you very much.
All right. But the rooms are now open and you can join there together with your group. Or are you able to go there? Do you see the button?
Yeah, we can go. We can go there, but for me, I just don't see the reason for now. So
Okay.
yes, yeah, but we can do that.
Can I have a question?
Yes.
When we have one machine to access,
Mhm.
do we have to take into account on the risk? If we cannot do that, is there a minimum limit of quantity of the number of the risk that we must include in our Excel?
No, I don't have such a limit, but I would say that I haven't given any limit, but I have a feeling that in no matter what is the machine, still I think that something like 5 you should be able to find quite easily. Was that an
Yeah, okay.
answer to you? A good enough answer to you?
Yeah. Thank you.
Okay, but now if you don't want to go to the breakout rooms now, then I think that the lecture for today is ended. I can still be here and answer your questions, but I have no other new things to say. So
Okay, thank you for the lecture. Goodbye.
bye.
Excuse me, Simo.
Yes.
Sorry. Can you see can you make the group member visible?
What group name? What do you mean?
I want to go to the group C because my friend created the group in group C, but it shows that it is already reached the maximum number, and he says that there is only 2.
I see 4 people in this group C.
Can you name them? What about group A?
And in a group A, there is only 2 people.
What is his name?
Tan and Kang.
No. Okay.
And in group D, there is only 1 person.
I don't know him, so
Okay.
can you make the name visible in Moodle so we can look?
Yes,
look
maybe.
there.
Yes, a moment. I will change the settings. So you are not seeing the other name?
No.
Okay. Mhm. According to this, I think you should be able to see the groups. The settings are such that you should be able to see the names.
It says that member list not available, and there is only one option that become member of this group.
Okay. Because there is an option that hide group members for students, but it is not activated. Are you sure that you are in the correct place, this risk analysis groups?
Yes, I'm in correct place.
Yeah, can you share the screen so that I will see how it looks?
Okay. Can you see my screen now?
Yes, I can.
This is the group, right?
Mm.
And
Member list not available.
And
And if you update now, is it? Okay, I can see that there are just new groups, but is it the same for all of you?
Yes, it's same to me.
How it is possible? Because according to the settings that I have here, it should be different. Okay, if I share the screen now, you can see how it looks. So this is the settings of this risk analysis groups, and there are these permissions and settings. Participants can join groups, can leave groups, can create groups, can set the name, can set and edit group descriptions, but you are not able to set any password. And there is an option that hide group members for students, but it is not activated, so I don't understand. But anyway, there is the list now. Okay, so I don't know why you are not able to see it, but is this enough that you will see now who are the members?
Not yet, but I can go through the group member whom I know. So for me, it's fine now.
Okay. All right.
And Simo, that I haven't submitted the previous exercise. So how to send it to you?
Wait a moment.
Excuse me, may I ask a quick question after you answer Sura's question?
Mhm. Yes, for Surai, I will make it possible so that you're able to submit it in Moodle.
Okay, thank you.
Okay, Danila, what was your question?
Yeah, my question is about the risk analysis. It says here that we need to be more specific in our machine selection. So it's not like chainsaw, but something else. So
Yes. It means that don't pick just chainsaw in general, but if you pick chainsaw, you need to say that it is a Husqvarna R25 jet or whatever it is, meaning that you will specify that it is exactly certain machine.
So model is needed.
Yes.
So for example, we don't need, we cannot say that we selected a stone crusher, but we selected a stone crusher that is, and the model, like name.
Yes,
So,
or the stone crusher, what is located in a factory, this and that.
Okay, thank you.
Yes.
Got it.
Okay, but now I think that we are done for today. I will close the Zoom and see you next week.